All right, Calc kids, this is section 10.1. This is the start of chapter 10, which is more on trig functions. Um, this is having to do with trig identities and verifying trig functions, simplifying on either side of an equal sign and things like that. So um, what I'm going to first tell you is this box that you have on section 10.1, that very, very large box. Some of these you probably know already, but if you don't, go ahead and write those down in your unit circle. At the bottom of your unit circle, it might, I don't know, look something like that written in there. I will also, attached to this section, I'm going to go ahead and give you the link for this document, I think. So if you want to print one of these out, you can, with all those typed on the bottom of it. So either write them on the bottom or print this document out that I have attached to your section. Okay, so the reciprocal identities are the ones that you probably already know, like cosecant is 1 over sine, it's the inverse of sine, secant is 1 over cosine. And those quotient identities, sine over cosine is what tangent is, and cotangent is the opposite of that. The Pythagorean identities are what we've kind of talked about before. Sine squared plus cosine squared equals 1. That's the one that you'll use the most out of the three. I have a poster in my room in the left corner of the room that is sine squared plus cosine squared equals 1. The cofunction identities are sine of pi over 2 or 90 degrees minus any value is the same thing as what cosine of u would be. So like sine of, let's say 90 minus 30 degrees, which would be sine of 60 degrees is the same thing as what cosine of 30 degrees. Sine of 60 is the same thing as what cosine of 30 is. Or tangent of, let's say, 90 minus 45 degrees is the same thing as what cotangent of 45 degrees is. So those are the cofunction identities. Another way to help simplify stuff down below. Even and odd identities, so sine of negative u is the same thing as negative sine of u. So if I have like sine of, let's say, negative 30 degrees, which would be like sine of 330 degrees, that's the same thing as negative sine of 30 degrees. You can look those up on the unit circle if you want to, but those are just ways to help simplify some functions down below. So the first example, evaluating functions, we have secant of u. Secant, if you look up above here, is 1 over cosine. If cosine is, let's see, cosine is adjacent over hypotenuse, so secant would be hypotenuse over adjacent. So the hypotenuse side here of some triangle that we have is negative 3, and the adjacent side is 2, or positive 3 and negative 2. It says tangent is greater than 0. Okay, so this information right here tells us a couple different things. We're looking at a coordinate plane and we're trying to figure out what quadrant we are in. So secant is negative in that case. If secant is negative, that means that cosine is also negative, because cosine is the opposite of secant. So cosine would just be negative 2 over 3. So cosine is negative. And from your unit circle, you might have written on there that cosine is the x coordinate and sine is the y coordinate. So we're looking at quadrants where the cosine or the x coordinate is negative. X coordinate being negative, here are the positive x's, here's the negative x's. So we're looking at either the second quadrant or the third quadrant. Okay. Now tangent being greater than 0 tells us that narrows down which one it is, the second quadrant or the third quadrant. So in this quadrant right here, the cosine variable is negative, but the sine variable is positive. So that's what we've got going on there. Down in the third quadrant, the cosine variable is negative, the x variable is negative, and the y variable is also negative. Tangent is sine over cosine. So if we put a positive over a negative, that would make tangent negative, which means it's not greater than 0. So we're not looking at something in the second quadrant. We're looking at a negative over a negative, which actually makes cosine positive, or tangent positive, so it's greater than 0. So we're looking at a triangle that's actually in the third quadrant. Okay. So our hypotenuse is 3 and our adjacent side is 2. Hypotenuse is 3, adjacent side is 2. And one of those has to be negative. So either the negative goes with the 3 and or the negative goes with the 2. The hypotenuse will never be negative, so that 2 has to be negative. Then we have to figure out what this side is using the Pythagorean theorem. So let's see, let's call it x squared plus negative 2 squared equals 3 squared. And we've got 4 here and 9 here. So x squared equals 5, and this is going to be the square root of 5. Okay. Now, it's not just the square root of 5 since it's in the third quadrant. It will be negative square root of 5 because you're going down that value. So negative square root of 5 is what that's going to be. So here's what I have my triangle looking like. And then from there, I just fill in the sine of theta. And theta will live right here in this corner. Cosine of theta, tangent of theta, cosecant of theta, secant theta, and cotangent theta. And I'm going to fill these in real fast because I'm assuming that you guys kind of already know how to do this. Sine is opposite of hypotenuse, so negative square root of 5 over 3. Cosecant will be negative 3 over square root of 5. Or when you rationalize, will be negative 3 square root of 5 over 5. Scoot over. Cosine will be negative 2/3 because secant was negative 3/2 from what we were given above. Tangent is, that's the opposite of our adjacent, so negative 5 over, or negative square root of 5 over 2, negative 2, so it would make it positive. 2 over the square root of 5, or 2 square roots of 5 over 5. And that's that problem. Okay, so it kind of seems like a lot of work, but it goes pretty quick once you know what you're doing. So simplifying a trig expression, there's this one here. We have two terms, this one here and this one here, separated by a minus sign. The first thing I look at is, do those two pieces have anything in common? Well, they both have a sign in common. So sine of x is what we're going to pull out in front. That will leave us with cosine squared x minus 1. Well, from our Pythagorean identities above, we have that sine squared plus cosine squared equals 1. Okay, so if I'm looking at, let's see, cosine squared minus 1, I know that sine squared plus cosine squared equals 1. So if I'm solving for sine squared, that equals 1 minus cosine squared. But I want cosine squared minus 1. So this right here, flipped around, would make negative sine squared. If I flip those two around, that would be negative 1 plus cosine squared. So this guy can be replaced with negative sine squared. So I've got that sine on the front, and negative sine squared x is what this piece is. And when multiplied together, that gives me negative sine cubed of x, and that's my simplification. Okay, if I'm going too fast through any of this, feel free to rewind and talk with each other about what some of this stuff means if you don't understand. Okay, I'm going to flip onto the back side. So factoring. So now we're breaking stuff down instead of simplifying. So secant squared theta minus 1. This would be, if we're factoring, secant squared theta minus 1 is secant theta minus 1 times secant theta plus 1. That is a difference of squares, because I can take the square root of secant squared and I can take the square root of 1. So difference of squares, one of them is minus, one of them is plus. That's all that we were wanting to do. 4 tangent squared theta plus tangent theta minus 3. It might help you to think of this as 4x squared plus x minus 3. Let's just treat it like they're x's, okay? And this is a complex trinomial, which means we're going to have to use the factor by grouping. So we look at the 4 and the negative 3. 4 times negative 3 is negative 12, and what I want to do is I want to find two numbers that I can multiply together to give me negative 12, but when I add them, give me a positive 1. And that's going to be 4 and negative 3. So I write this middle term here as the two pieces 4 and negative 3. So I've got 4x squared plus 4x minus 3x minus 3. So I left this guy alone. I left this guy alone, and then this 1x broke it down into 4x and minus 3x. So I've got this going on, and now I do my factor by grouping. So I can pull a 4x out of here, and I'm left with x plus 1, and I can pull a negative 3 here, and I'm left with x plus 1, and that will give me 4x minus 3 times x plus 1, but they're not x's. I just used x to try to simplify things. It was originally tangent of theta. So I'm just going to replace my final answer with 4 tangent theta minus 3. And it's going to be tangent theta plus 1. There we go. Now he's completely factored. Right? This last one right here is what's called a difference of cubes. And I don't know the complete formula for, I don't have it memorized anyway. The formula for difference of cubes. So I went ahead and wrote it down. And if you want to write that down also, that would be a good idea. If you have a difference of 2 cubes, meaning like the first piece is something cubed and the second piece is something cubed. Like I can take the cubed root of sine cubed and I can take the cubed root of 8. Okay, and it's written as minus. It would just be x minus y times x squared plus x times y plus y squared. So what might be the easiest thing is to identify what our x is and identify what our y is. Okay, if this is what x cubed is, then just x would be sine of theta. If 8 is what y cubed is, then just y would be 2, since 2 cubed is what 8 is. So that's our x and that's our y. So to break him down, he will look like sine of theta minus 2, because that's the x minus y part. And then I have sine squared theta plus sine of theta times 2, because that's x times y, or 2 sine of theta plus y squared. And since y is 2, that would give us 4. And that's how you break down a difference of cubes. So here's the answer for this one. That's factored down. This one here, and this one here. Okay? Again, if I'm going too fast through any of this, pause. All right? Factoring a trig expression. So I notice in this one that the trig functions that I have are 2 different ones, cosecant and cotangent. So what I want to try to do is simplify that if I can by using one of the expressions on the unit circle. So, or flipping over to the front side of this page. Anytime I see something that's squared, a trig identity, I always try to use one of the Pythagorean identities. So cosecant squared, if I look over here, cosecant squared, theta is 1 plus cotangent squared. So I'm going to go ahead and replace that with 1 plus cotangent squared. And that's minus cotangent x minus 3. All right? So I replaced this guy with 1 plus cotangent squared. And then this guy, I can combine with some of these pieces. So I've got cotangent squared minus cotangent minus, 2? If I combine the 1 and the 3, minus 2, and it looks like that. Okay, I get really lazy with not putting my x's in there, but there's an x that follows after all of these. Okay. So cotangent squared minus cotangent minus 2. I'm going to do kind of what I did up here for factoring this stuff down. If I don't want to think about the cotangents, this is just like factoring x squared minus x minus 2. So what we're trying to do is find two numbers that multiply together to give me negative 2, but when I add them, give me negative 1. And that is negative 2 and positive 1. So it will look something like x minus 2 and x plus 1. And that's completely factored down, but they're not x's, they're cotangents. So cotangent x minus 2 and cotangent x plus 1. Okay, and that's how he is factored down. All right, simplifying a trig expression. Again, I've got multiple things going on here. All right, 2 pieces separated by a plus sign. I look to see if there's anything that they have in common that I can pull out, and there's not. So what I usually resort to then is taking everything and trying to write it as a cosine or a sine. So this is sine, this is a cosine, but this cotangent, I can write him. Cotangent is cosine over sine, so this would be sine of t plus cotangent is written as cosine of t over sine of t. And then I have times cosine t. So I'm just going to take him and rewrite him as cosine t sine t over sine t. All right. Then I've got, let's see, this stuff going on here. this would be like cosine t over 1. So I've got sine of t plus cosine t, or cosine squared t over sine of t. That's kind of what I've got going on now. If I want to combine these two pieces, this is like sine of t over 1, so I want to find a common denominator, and it's going to be sine of t. In order to get this to be a denominator of sine of t, I've got to multiply by sine t over sine t, like that. Okay, and up top here, that will give me sine squared t, put these two pieces together, plus cosine squared t, all over sine of t, and this is a Pythagorean identity. Sine squared plus cosine squared equals 1. So I've got 1 over sine. Well, that's an identity also. 1 over sine is the same thing as cosecant of t. And all of this up here simplifies down to just cosecant of t. And that's it. Okay? This one they want us to perform the addition. And in order to add, like we did up here, we have to find a common denominator. 1 plus cosine of theta and sine of theta don't really have anything in common, so what I'm going to do is I'm going to multiply this piece over here by sine of theta over sine of theta, because that's what it's missing from this denominator here. And I'm going to multiply this piece by 1 plus cosine theta over 1 plus cosine theta. And that's what I'm going to do to that. Okay, so let's start with this first piece. Sine of theta over, or times sine of theta is, I'll put it over here, sine squared theta, okay, plus, I'm going to work with this left side, or this right side, so cosine theta times 1, and cosine theta times cosine theta is cosine theta plus cosine squared theta. All right, on the bottom part, I want to multiply that together. Let's see, let's just leave it separate. Sine of theta times 1 plus cosine theta. I don't want to multiply it together just quite yet. Okay? Yeah. That's how I want to leave it, because this is going to come out really nicely. Sine squared plus cosine squared, even though they're separate pieces, I could write them together, and then sine squared plus cosine squared equals 1. So on the top I have 1 plus cosine theta. That comes out really nicely. And then sine of theta times 1 plus cosine theta. The 1 plus cosine thetas cancel out, and that gives me 1 over sine theta, which again is cosecant. Cosecant theta, just kind of like it was up here. All of this stuff reduces down to just a cosecant, which is super, super nice. Okay? All right, last one. Trig substitution that removes a radical. So use the trig substitution, or use the substitution x is 2 tangent theta. All right? And then they tell us that theta lives between 0 and pi over 2. So thetas are going to be somewhere between 0 and 90 degrees. Don't so much worry about this part right now. What we're going to do is we're going to take this 2 tangent theta and we're going to plug it into this equation right here. So I have the square root of 4 plus, instead of it being x squared, it is actually 2 tangent of theta squared. Okay? All right. So what that's going to do here for me is I'm going to get rid of that parentheses by squaring it. So I've got 4 plus 2 squared is 4, and tangent squared is tangent squared theta. So this is what I've got going on here. Right? I just squared that stuff in parentheses to get rid of it. So, all right, now I have 2 pieces, 4 and 4 tangent squared theta. So I'm going to pull a 4 out. And I've got 1 plus tangent squared theta, which I think is a Pythagorean identity. And let me check. Pythagorean identity, 1 plus tangent squared theta is secant squared. Yes, perfect. So this is actually the square root of 4 secant squared theta. And since I can take the square root of both of those things, the square root of 4 is 2, and the square root of secant squared is just secant. This is just 2 secant of theta. That's it. Okay? And we're done.